Good morning, freshmen. Mr. Martineau here, bringing you another lecture from the House of M. Miss Mandrelli once again on the camera. Today we're going to...
Toonsis on the couch.
On the couch.
Okay.
So today we're going to keep going with waves a little bit. You've learned about characteristic of waves, so we've talked about their amplitude, their wave height, their frequency, their period, their wavelength, and all of that sorts of things, what the graphs look like for waves. But now we want to talk specifically about different types of waves and where we see them in nature. So to do that, we're going to go to the graphic organizer. So one thing that all waves have in common is they all transfer energy. So we keep saying energy can't be created or destroyed, it can only be transferred. Okay, well, that's great, but we're not explaining how energy actually does get transferred, and it does it by means of a wave. So all waves transfer energy, and there are two types of waves. So every wave in the universe can be classified as one or the other of these two types. The first type are mechanical waves, and the next type is electromagnetic waves, or EM waves, or we also call those light waves. So let's go back to mechanical. Mechanical waves start with an M, they're physical waves. Let's go to the next one. And when we say electromagnetic waves or EM waves or light waves, we are all saying they're all the same thing. So just in case you see that come up in different ways, wait, I thought, is this an EM wave or is this a light wave? They're all the same. Okay, so let's go back to mechanical waves. So there are different ways that mechanical waves and EM waves can transfer energy. So here's how mechanical waves do it. Mechanical waves must move through a medium. What's a medium? Well, it's somewhere between a small and a large. Yeah! No. A medium is any type of substance that can be vibrated, right? That you can come in contact with. And media is basically a solid, a liquid, or a gas, right? So mechanical waves must move through medium. So there's your M there. Mechanical move through a medium. And again, a medium is anything that can be vibrated. In this case, we're going to call that a solid, a liquid, or a gas. So what makes an electromagnetic wave different is that an electromagnetic wave can move through empty space. So electromagnetic, EM empty, empty space. So basically, EM waves or light waves can go through a vacuum or go through space, from the sun to here. And they don't need to vibrate anything. Well, moving over back to mechanical. Mechanical waves must move through a medium, a solid, a liquid, or a gas. Moving on. Okay, so how do they actually transfer energy? Well, mechanical waves transfer energy by particles colliding with other particles. So if you want to think about balls on a pool table, okay, and one ball hits a second ball and the second ball goes flying, well, that's a kind of the way that what happens when little particles collide with each other. And those particles can either be made up in a solid, they can be particles in a liquid, or they can be particles in a gas. And those all behave differently, and you'll learn about that next year in chemistry, how particles behave in solids, liquids, or gases. But mechanical waves have to transfer energy by actual collisions with particles. But electromagnetic waves, EM waves, transfer energy through alternating electric and magnetic fields. What does that mean? Well, you don't have to worry about that so much. If you're really curious about that, then you would take my AP or regular physics class as you become upperclassmen, which I suggest, and we would go a little more in depth on exactly what alternating electric and magnetic fields mean. So for right now, if you're really curious, just memorize that part. Just understand that EM waves are electro and magnetic fields alternating. But past that, you don't need to understand that right now.
There are no particles bumping into particles.
There are no particles. It's just these weird things called electro and magnetic fields. All right, so we're going to move back over to mechanical waves, and we're going to... Well, how fast do these things move? Well, mechanical waves are the waves that we deal with on an everyday basis, and that can be water waves or sound waves or anything like that. And they can move anywhere from something very slow to 1 centimeter per second to something very quickly, 10,000 meters per second. But all of these speeds are slow compared to light waves. So 10,000 meters per second is really fast. That's like Mach 30. It's 30 times the speed of sound. And that's really quick. That's still really slow compared to light waves. So moving on to light waves. Light waves comparatively move at 3 times 10 to the 8th meters per second. That's a 3 with 8 zeros in front of it. That's 300 million meters per second, or in the English system, 186,336
Sorry.
sorry, miles per second. So that means if light started, it would go around the equator 7 times in a second. Or, if you want to look at it this way, if you had a train that went the speed of light, and that train was on a track that went around the equator, and you stood at the equator, the train, as it runs on the track, would run you over 7 times in 1 second. As it went around the world. So, it's fast.
It's fast.
So, the bottom line here is that mechanical waves can be very slow or very fast compared to what we're used to, but still very, very slow when compared to light. And now let's look at different examples of waves. As I said before, sound waves are mechanical waves because sound wave particles of air bang into each other to create sound. You can't have sound without air. You can't. It's impossible. So you can be floating in space and try to scream your lungs off and no one's going to hear you because nothing's going to happen. So when you hear explosions in Star Wars in space, can't happen.
No.
So sound is an example. Water waves are an example of a mechanical wave. Water particles banging into each other. Seismic waves, you've got soil particles, rock particles banging into each other. And just any old vibration. So if I do that and you felt that, like if I were here in the kitchen, I did, Miss Mangiarelli probably felt
I
the
felt
vibration in her foot. Well, that's a mechanical wave. Almost like a little seismic wave, if you want to look at it that way. Let's move on. E&M waves, examples are radio waves, microwaves, infrared waves, visible light, ultraviolet light, X-rays, and gamma rays. That's what we would call the electromagnetic spectrum, which we're going to talk about in coming weeks. So that is your introduction to 2 different types of waves that are available to us in the universe, mechanical waves and electromagnetic waves. If you have any, just make sure you read this, take notes on it, be aware.
Well, this we're gonna actually
that's right.
give to them.
We're going to give you this sheet so you can use it as notes, so there's no excuses for getting those parts incorrect. We have more videos coming later in the week, so I hope you enjoyed this. Yeah. The cat will still be sleeping probably. And thanks a lot for your time. Stay well, and we'll see you soon. Bye.
Bye.